We're going to look at the first part of the Lab 5 instructions. So we're going to be concerned with identifying what a function actually is and evaluating functions. And so a function is a special case of a relation. So to know what a function is, we have to first know what a relation is. And it's a set of ordered pairs. It's also described as any correspondence between two sets. So let's go, and I've got these instructions, um, just the setup on a different page here, and I'll go through that. This could be considered a relation. And I have a set of teachers, and they correspond. There is a correspondence from the teachers to a set of students. And in any relation, when you're going from left to right, the first set is called the domain, and the second set is called the range. So my domain would be the actual set of teachers, which would be Dr. Hamilton and Mr. Smith. And the students would be the range, and so that would be Tom, Rick, Ann, and Lee, if we were going to list those as sets, which we do. And you can see that you have a correspondence. From your domain, Dr. Hamilton is paired with Rick, but Dr. Hamilton is also paired with Ann. And so you can see that in this pictorial representation, Mr. Smith is paired with Tom and Lee. Now, another way that you could describe this relation is from this set of pairings. And as you can see, Dr. Hamilton is first paired with Rick. And so we have that like coordinates of a point, a first entry and a second entry. Dr. Hamilton is also paired with Ann. Then Mr. Smith is paired with Tom, and then Mr. Smith is also paired with Lee. And so your first entries are elements in the domain, and your second entries come from your second set, which is the range. That's another way you could list this relation. We also have a relation here between a student and an eye color. And so you can see here from the picture, this is our domain, my set of students, and our range is the set of eye colors. And then that same pictorial representation could be written down in as a set of pairings. And the first entry comes from the domain, and the second entry comes from the range, as you can see here. And if all you had to start with was this, and you were asked what is the domain and what is the range, the domain is going to be the set of first entries. So the domain would be Tom, Rick, Ann, and Lee. And the range would be the set of second entries. Now we would not write brown twice because remember you don't have repetitions in set theory. So I wouldn't write brown, brown, blue, brown because that would not be a set. Okay. And here's another example of a relation. We have three relations here. And so the domain here would be the set of animals. So dog, duck, rabbit. And the range would be the lifespan. And this is a pictorial representation, but this is also the same representation of that relation. So you have a set of pairings, and you can see dog is paired with 11 years. You can see duck is paired with 10 years, and rabbit is paired with 7 years. Now, all three of those are relations. A relation is a correspondence between any two sets. Not all of these are functions. So that gets us to our definition of what a function is. And so we come here to our definition of what a function is. So let me copy that. A function is a special case of a relation. And so I'm going to put that here. A function is a special case of a relation that happens when every element of the domain is paired with exactly one, and no more than one element in the range. Okay, so if we go back, could we identify which of these are actually functions? So let's just work our way backwards. Is this a function? Well, I go through the domain. Dog is in the domain, and it's only paired with one thing in the range. So far, so good. Duck is in the domain, and it's only paired with one thing in the range. And rabbit is in the domain, and it's only paired with one thing in the range. So this is a function. All right. Now, what if you had this notation and you didn't have this, and you were asked, is this a function? Well, you go through and you look and see if there's any repetitions. And if there are any repetitions in the first entry, you do not have a function. So you can see dog is not repeated as a first entry anywhere else. So dog is only paired with one thing. So far, so good. Duck is not repeated as a first entry anywhere else. So duck is only paired with one thing in the range. Rabbit is not listed as a first entry anywhere else, so rabbit is only paired with one thing in the range. So it is okay. So when you have this form, you look to see if none of the first entries are repeated as first entries, you have a function. Let's go back to that first example. Is that a function? Is this a function? And if we look at the pictorial representation, Dr. Hamilton is paired with more than one thing in the range. So this is not a function. Now, also, Mr. Smith is paired with more than one thing in the range. But once you find it where it breaks the rule once, you don't have to look any further. It's not a function. Now, what if you didn't have this representation and you were given this representation and asked, is that a function? Then you're looking to see if there's any repetitions of first entries, and you have Dr. Hamilton repeated as a first entry. So this is not going to be a function because Dr. Hamilton is paired with Rick in the range, but Dr. Hamilton is also paired with Anne in the range. Dr. Hamilton is paired with more than one thing. So if you have a repeat of any first entries as first entries, then you do not have a function. And finally, what about this one here? Is this going to be a function? And I say that this is a function. So here's the pictorial representation. Tom is only paired with one thing in the range. It's paired with brown and not any other color. Rick in the domain is only paired with one eye color in the range. Rick is paired with brown and not any more than one color. Anne is paired with blue eye color and not any more than one. So that's okay. And Lee in the domain is only paired with one eye color. So yes, this is a function. If we look at this representation and you were asked, is that a function? Well, Tom is not a first entry anywhere else. Rick is not repeated as a first entry anywhere else. Anne is not repeated as a first entry anywhere else. Lee is not repeated as a first entry anywhere else. So this is a function. Now, when you have a function, you can give it a name. And typically, lowercase f is the most popular name to give a function. And lowercase g or capital F, but most common of all is lowercase f. So this is a function, and so I'm going to call it lowercase f. Now, what if you were asked, what is f evaluated at an? Or what is f of an? When you see something like this, it's asking you, what does f, where does f pair an with? What is an paired with in the range? And you can see that f maps an to blue if I'm looking at this drawing. Now, if I don't have this drawing, but I was still asked the same question, what is f of an? Where does f take an? You look at this picture and you find an in the domain, so in the first entry, and f maps the first entry into the second entry, so f evaluated at an is equal to blue, or f maps an into blue. Okay, so we did decide that this was a function, so I'll call this g. And where does g take or map the rabbit? And you can see from this picture, g maps the rabbit to a life expectancy of 7. Now, if I call this g, what is g evaluated, or where does g take the rabbit? And you can see here, g maps the first entry into the second entry, and we get the answer 7. All right, so let's go on to an example that you would see more often in algebra, because we don't use words. This is more often than not what you will see. So it's definitely a relation, but is it a function? So let me just get h over here and make it a little bit. Is that a function? It's definitely a relation. What if you asked what's the domain and the range? Why don't we start with that? So it's definitely a relation, and all relations have domain and range. So the domain is going to be the set of first entries, and so I'm going to have -1, then 2, then 0, then 3. And the range is going to be the set of second entries. So I've got 7, 0, -1, and then 7, but 7's already in my set. And remember from our set notation, you can't have repetitions. So that's my domain and my range. Is h a function? Well, to tell whether it's not a function, look for, are there going to be any repetitions of the first entries as first entries? So let me get this up here. -1 is not repeated anywhere else as a first entry, so we're okay. 2 is not repeated anywhere else as a first entry, so we're okay. 0 is not repeated anywhere else as a first entry, so we're okay. And then 3 is not repeated anywhere else as a first entry. So I've gone right through the list, and so this is a function. Okay, so if I've got another set that looks like this, this is not a function because you have a first entry that is repeated as a first entry. Now, again, make sure we're clear. -1 is repeated here, but not as a first entry. So it doesn't matter. This one here doesn't matter. -1 is not repeated anywhere else as a first entry. And we've gone right through the list of first entries, and it's not repeated. So it is a function. Now, what is h evaluated at -1? So what a function does is it maps the first entry into the second entry. So this is called h. So I'm going to look for the pairing that has -1 as my first entry. And so here it is. And what does H do with -1? It maps it into the second entry. And so H evaluated at -1 is equal to 7. And my answer would be 7. Okay, so let's go back to the lab or the examples, and let's have a look at that. So this is the example that we just did in class, just did together. Okay. And then I'm going to do example 5, and I'm going to stop the video because my dog's getting jealous. All right, won't be long. Okay, let's look at this. Now, suppose we have a function where the function is an equation. How do you evaluate a function that's an equation? Well, I have my equation right here. And what I'm going to do is whatever is inside the parentheses there is going to be my x-up value. So wherever there's an x, I'm going to replace it with -3 in parentheses in this equation. And now I'm going to get a number. And this is why it is important that you put the -3 in parentheses. If you don't put the -3 in parentheses, that is equal to the number -9. But this is equal to the number +9, because when you square the negative symbol, it becomes a positive number. So I'm going to have 9, then +6, +1, which will be 16. So f evaluated at -3 is equal to 16. My answer is 16. Now let's look at this one. What do we get for that one? Well, I'm going to take my original formula and I'm going to write it without the x. Everywhere there's an x, I'm going to replace it with blank parentheses. That's the first thing I'm going to do. Okay, I'm going to replace the x with blank parentheses. And now, what's going to go inside those blank parentheses? X plus 1. Now, what I've written here is a correct answer. However, you won't see it like this as a multiple choice selection. It's going to be all multiplied out. So it doesn't do you any good to get to here and to stop. We have to write this out where everything's been expanded and like terms have been gathered. So x plus 1 all squared, remember, is not x squared plus 1 squared. It's x plus 1 times x plus 1. Then I distribute -2x, then -2 times +1, and then this plus 1's coming along for the ride. Now here I'm going to have to FOIL x squared plus x times 1 plus 1 times x plus 1 times 1. -2 plus 1 is -1. So I'm going to have x squared. X plus x is 2x. And plus 1 minus 2x minus 1. Okay, and so I have a 2x and a minus 2x there. They cancel. I have a plus 1 and a minus 1, and they cancel. So at the end of all of that, I'm left with the answer x squared. And that is how you would see it as a multiple choice selection. You would never see it looking like this. And again, if we look at the lab, okay, so this shows you how we got f evaluated at -3, and then how we got f evaluated at x plus 1. So we took our formula for f and we write it without the x. So the next thing I want to do is write the formula for f with blank parentheses. in place of the x. So I'm just going to have and then the next is you replace we put x plus 1 inside the parentheses and simplify. Which is what we did there, and that's how we got our result x squared. Okay, so that finishes this section on the lab, and so I'm going to stop